Hello, my name is Barak Pelman. I'm an architect, educator, and researcher at Bezalel Academy of Art and Design in Jerusalem. I'm the director of the Hybrid Pedagogy Lab, a new research group focusing on design education and pedagogy. I'm also a faculty member at the Architectural School, where I lead the unit dealing with the role of materials and technology in architectural design. My PhD thesis, which I'm writing at the School of Computer Sciences and Engineering at the Hebrew University in Jerusalem, focuses on the role of materials and craft in architectural education. In this presentation, I will explore the impact of sociomaterials on collaborative learning processes in virtual and physical design studios. Architectural design is bound up with materiality, and architects routinely incorporate materials practice such as model making and drawing in their design processes. These practices are not simply used to convey an architectural vision or execute a plan, but they also hold a crucial role in developing design ideas. However, in the last 3 decades, advanced CAD, CAM, and online communication have paved the way for the development of virtual design studios, which became a mainstream educational method during the COVID-19 pandemic. In virtual design studios, face-to-face interactions are replaced by synchronized online communication platforms, such as video conferences, tool, and online messaging platforms. Physical spaces are replaced with virtual learning environment, collaborative whiteboards, and social media. And lastly, physical interaction models and drawings are replaced with virtual ones that can be presented on the above-mentioned digital platforms. Virtual and physical design studios are therefore characterized by different materials environment, and therefore encompasses different learning opportunities. This ethnographic study explores how these differences affect collaborative learning processes in the architectural design studio. It employs a sociomaterial approach, which I will explain in a minute, to analyze these two discrete tutorial sessions of architectural projects. The first is within physical design setting, and the second is within visual design studio setting. The study employs a microanalysis approach, examining the dynamics of material interactions, utterances, and body gestures in the collaborative learning processes involved in architectural education. So what is sociomaterial approach, and why it is suitable for this study? The concept of sociomateriality was originally developed in organizational studies. It suggested that materials possess social and cultural meaning, and therefore have both material and social affordance. Thus, the interactions with materials involve both their material properties and their social dimension. For Orlikovsky, no materiality exists independently of the social dimension. The two are intertwined and entangled and constitute each other. Therefore, materials are best described as sociomaterials. Building materials are a good example of that, as they are shaped by severe regulations and technology, both of which are an outcome of social forces. Therefore, buildings' materials are entanglement of material and social construct. Social materials approaches widen the view of materiality from the physical domain to the virtual. One of Orlikovsky's example of the entanglement of the social and the material is the Google search engine. Orlikovsky reminds us that the architecture of Google search engine involves multiple services, directories, databases, indexes, and algorithms, and reflects human considerations made about their design, constructions, and operation modes, all which are highly social. By widening the scope of materials into the virtual world, the sociomaterial approach allows us to analyze virtual models, virtual spaces, and digital interfaces, and therefore enable us to study both virtual and physical domains. When sociomateriality was adopted in educational research, it became an umbrella term for various theories. Fenwick encompasses under this term 4 theories: actor network theory, spatial theory, complexity theory, and cultural historical activity theory. While deriving from different roots, these theories share some commonalities. First, they all take whole system into account and explore the web of entangled human and non-human action in knowledge creation. Second, they all trace interactions among humans and non-humans and focus on relations and mediations. And third, they share a standpoint where learning is viewed as an effect of multiple interaction within sociomaterial assemblages, incorporating human and non-human agents. Recent development in cognitive science support this perspective by providing possible explanation for how interaction with material can support cognitive processes. Cognition in Western society was traditionally understood as something that happens inside the head. However, contemporary perspective challenged this view by extending the boundary of cognition first from the head to the rest of the body, what is commonly known as the embodied cognition theory, and then to the rest of the physical world, i.e. the distributed cognition theory. They suggest a model that view cognitive processes as constantly changing emergent processes that arise within a complex system comprising the brain, the rest of the body, and the physical and the social environment. But how exactly does this work? How do materials can be integrated into cognitive processes? Clark and Chalmers argue that objects can be considered part of cognitive processes if they perform a function that, if done in the head, would be recognized as part of the cognitive process. In his article, Visualization and Cognition, Latour claims that different types of visualization, such as diagram, map, graphs, and have different cognitive affordance and limitations. Hutchins argues that the reason for this is that objects can save mental effort since they already do part of the computation. However, saving mental load is not the only way materials can influence cognitive processes. They can also evoke emotions and associations that integrate new and possibly unexpected information into the process. These emotions and associations can be brought forth due to the cultural symbols that are embedded in the material or the connotation elicited by individuals. Designers are trained to predict some of these emotions and associations and use them in the design process. As a result, they can affect some of the user's cognitive processes. For example, Latour argues that a gun is not a neutral or passive tool, but an active and influential agent that can change the way a person thinks about violence, responsibility, and morality, and even influence their decision to shoot. The person holding a gun develops a new identity, a gunman, a new hybrid constitution of the person and the gun, and is influenced by the gun's design. Latour goes further with the idea of its moral consequences, claiming that in this case, neither the human nor the gun alone can account for the shooting action, but rather the hybrid of the network of human and non-human actors that constitutes the situation. This is not detached from reality, as the case of liability of gun makers for shooting is a central debate in the USA. Although the Protection of Lawful Commerce in Arms Act, PLCAA, has protected gun makers and dealers from liability for crimes committed using their weapons, several lawsuits against gun makers have won in court. Back to the study. As I mentioned earlier, the study analyzed 2 discrete sessions of architectural project held at Master Level School of Architecture in Spain. The first session was conducted online on February 15, 2022, while the second session was conducted one day afterwards, in person, on February 16th. Both tutorials were on the same subject, which was the development of structural architectural concept, and with the same group of students. However, they had different socio-material environment. The assumption was that by comparing these sessions, comparing these sessions would allow me to observe how these socio-material surrounding affected conversations and learning interactions. It does not intend to judge whether virtual design studio is better or worse than physical design studio, but to stress the importance of paying attention to the socio-material environment for comprehending the learning processes of architectural education. Moreover, this comparison could also tell us something new about the different qualities of online and physical learning dynamics. For each session, I had 20-minute video clips, digital documents such as a slide presentation, and digital models that the student used, a few still images, and my own field notes. The analysis was carried out in 2 phases. During the first phase, the session structure was examined and compared. The second phase focused on how socio-material were integrated into the conversation to create a mutual understanding of the project. For the first stage, each session was transcribed and unit of interactions were analyzed. Interaction was defined as an event that involved spoken output from either the students or the tutor, as well as any interaction with the physical or virtual material in the physical or virtual space. Most often, spoken outputs were accompanied by physical interaction with objects. In this case, the size of the analysis unit was defined by the length of the sentence. However, in some cases, interaction with object did not complement a nutrient, such as in case of silent thoughts. In such cases, the size of the analysis unit was defined by the start and the end of the physical contact with the object. I recorded each interaction in a spreadsheet, including its duration, the associated text, visible actor involved, themes discussed, my own comments, and sometimes a relevant image that illustrated the event. In the second analysis stage, I compared how sociomaterials were integrated into dialogue that took place during the session and contributed to the cognitive processes such as meaning-making and problem-solving. I used the dialogic analysis adapted from ASH and focused on two significant events, one from each session. I carefully selected extracts and examined different aspects of the interaction, including utterances, body gesture, tool use, interactions with models, and the visible actors involved. I interpreted the actual function of these interactions in the conversation. To better illustrate the material interaction and socio-material context in which they took place, I added screenshots from the video recording representing the moment analyzed. This helped me pay attention to the role of material interaction in the dialogue. These extracts represent two cases in which the tutor identified a potential design issue and collaborated with students and the materials to develop a shared understanding of them. The session structure is illustrated here, with the online desk grid at the top and the in-person session at the bottom. Each session was divided into stages, labeled with letters and title. The color schemes indicate the person leading the conversation at the time indicated on the timeline below. I have observed that the structure of the conversations differed between the virtual and the in-person session and was influenced by the socio-material environment. The virtual session's structure was primarily influenced by the slide presentation design and had fewer material interactions compared with the in-person session. The in-person session, on the other hand, facilitated more natural and spontaneous interaction, covered a broader range of topics, and made better use of the physical environment. The socio-material environment of the online session did not support the effective augmentation of experiential knowledge. This led to three issues. First, a limited ability to comprehend complex architectural and structural ideas. Second, there was a limited ability to address misunderstanding when they arose. And third, there were fewer opportunities to facilitate spontaneous interaction between different actors. I have identified several ways materials participate in the cognitive processes during the discrete learning processes. Firstly, materials store information by carrying graphical symbols and spatial relationships such as size, location, and proportions of their elements. This is quite obvious, but it still complies with our mission. Secondly, material can offer embodied experience that contributes to theoretical understanding. For instance, during an in-person session, the tutor physically engaged with models by testing them structurally, measuring their element with their fingers, and observing them from different angles. Thirdly, certain materials can support cognitive process better than others by organizing and visualizing information to create new relationships that are otherwise difficult to analyze. For example, when the student needed to understand the special characteristic of the residential unit they designed rather than structural properties, they changed the socio-material environment by incorporating objects that would support this process. Furthermore, I found the socio-material interactions can sometimes lead to unexpected outcomes. Although the socio-material may be designed to support a particular cognitive process, such as evaluating the structural behavior of a given design, interaction with material can reveal other design features and lead to different thinking paths. Lastly, socio-materials in architectural education environment are not static actors and can change their shapes and affordance during thinking processes. For example, when the tutor draws on a plan and change an element in 3D model, it also changes the context in which the other plans or model elements are understood. This process provides new affordance for new ideas to emerge. Architectural models and drawings represent possible realities. Therefore, they can be seen as metaphors that map certain qualities between familiar and unfamiliar domains. However, as happens regularly with language metaphors, the projection between different domains may be influenced by many factors, such as past memory, emotional states, and associations. Although it is sometimes difficult to control what is projected and what is remade in the source domain, Lakouf and Johnson argue that the essence of metaphor is understanding and experiencing one kind of things or experience in terms of another. Therefore, in their view, metaphors are cognitive tools that project both concepts and experiences. For instance, the materials used to construct the structural scale models in the source domain did not represent the materials of the final object that was imagined to be built in the real world. However, they can elicit emotions and associations that can be projected alongside the structural behavior of the model. This infusion of new information can take the cognitive processes in new and unexpected directions and possibly contribute to creative and innovative thinking. In the context of sociomaterial theories, viewing sociomaterials as metaphors help us to understand how the social dimension are infused into the architectural learning processes through material interaction. Going back to the example of the scale structural model, when a small wood stick is a column, it represents not only its role in stabilizing the whole structure, but also the social and the financial forces that affected its dimensions, transportations, and installation processes. To sum up, these study findings offer theoretical, methodological, and pedagogical contributions. Theoretically, it identified several ways sociomaterials contribute to the cognitive processes involved in discrete sessions. They store and contextualize information of different kinds, offer experiences that contribute to theoretical understanding, and act like metaphors that aid in communicating ideas. Methodologically, it stresses the importance of considering the sociomaterial when attempting to comprehend learning processes in architectural education. And pedagogically, it emphasizes the importance of choosing and designing the sociomaterial environment to support the intended learning processes. Thank you for listening.